Howdy, Precalc. We are starting using actual logarithms to solve questions. Now, this video is probably going to get a little bit longer than I wanted it to because I have a lot of examples on here. So, you can pause, fast forward, do whatever, but I go through, first of all, a bunch of strategies for solving, just 4 strategies, I think. And then I do a couple examples off each of the pages. You guys are going to have to go back and do the odds on those pages, and I'm going to go through and do the evens. So, watch everything. It would be helpful, but if you don't, I get it. All right, strategy number 1 is if a problem has a single power of x, isolate that and use a reciprocal power to solve. So this is when you have some crazy powers. So first here we would just divide by 15 to isolate the x. Whoops, equals 4 half power. I don't know how you can't write all of a sudden. All right, and then the reciprocal power here would be the 3 halves. So we're going to do this side, and I'm writing this over so that you can see what I did, to the 3 halves power. Okay, so that becomes an x to the first because you multiply those and they undo each other. You get 6 over 6. And then over here, this is a square root and it is cubed. You can do that in either order. Now, if you do 4 cubed, it's 64. The square root of that is 8. Or the square root of 4 is 2, and 2 cubed is 8. Either way, the answer is x equals 8. And you could plug it back in. 15 times 8 to the 2/3. Remember, it would do the 2/3 power first. So that would be 4 times 15 is 60. It works. That's an exact answer. Okay. This one we're going to divide by 3. And we get x to the 1.2 equals 19. Then we can do each side to the 1 over 1.2 power. Some of you realize that's 1 and 2/10 or 1 and 1/5 or 6/5. So it is equivalent to taking each side to the 5/6. But it's okay if you're not good with fractions and you just do it this way, okay? Erase that because I think it's going to be confusing on the notes. So this one, I think we're just going to have to type in on the calculator. 19 to the 1 divided by 1.2. Whoops. Is 11.6313 if I round to 4. And I want to show you why we round so long. If I just rounded that to 11.6, okay, and I went and I put it back in to the original question. The original, what happened here? The original question was 3 times 11.6 to the 1.2. Whoops. If I just do that, I get 56.8, which is not 57. If I put in the longer number, 3 times 1.6. 313 to the 1.2. Hopefully I'm going to get a lot closer to 57. Oh yeah, really close. Okay, so that's why we carry so many places. I'm not going to keep checking them for you. You can certainly check that these are right. I may check another 1 or 2 along the way, but that's why we carry so many places when we get a decimal. All right, if a problem has a single exponential expression, meaning the variable is in the exponent, you're going to isolate the exponential expression and then take the log of both sides. There is an exception to this. These are when they have the same base. If you have more than one in a problem and they have the same base, and we'll do some of those in a minute. Right now, you would divide both sides by 50 on this one. I don't want to make a silly mistake, so let me do that. Is 25. So we get 3 to the 2x equals 25. And then whenever x is in the exponent, you have to take the log of both sides. And it doesn't matter what kind of log you do. Okay. Then I'm going to move this guy out front. And then I'm going to divide. To get x by itself, I need to divide by the log of 3 and divide by 2. You could do that in one step. I think I'll show it in 2. I'm going to divide by the log of 3. And then we're going to divide by 2. But you could certainly put the 2 and the log of 3 down in the denominator. But you'd have to use extra parentheses, and I think someone will get it wrong. Try it how you want it to put, but just make sure you get the same answer that I'm going to get here. And then when I divide everything by 2, I get x equals 1.46497 or 1.4650. And if I plug that back in here, if I type 50 times 2 to the power of, oh, it was 3. 3 to the power of 2 times 1.4650, I get 1250.07, very close. Okay? All right, so this is the same kind of problem. I probably don't need to do another example, but I will real quick. Divide both sides by 6.6. You cannot, guys, over here you couldn't go 50 times 3 is 150, okay, because only this is to the exponent. Same thing here, you have to divide first. And 0.8 divided by 6.6 is a lovely 0.121212. Or you could do a math enter. And this is 4/33. If you wanted to be more exact till the whole way through, I really don't care. Then you're going to take the log of both sides, and I'm going to use ln this time just for fun. Move the x out front. I'm only using a different one to show you it doesn't matter. And then I'm going to divide both sides by the natural log of 0.5. Okay, and we're not condensing here. We are literally just dividing the log out. So we get x equals, I type ln 0.121212, close parenthesis, divided by natural log of 0.5 is 3.0444. Okay, please be typing, because if you're not getting these same answers, then we need to figure out where we're going wrong, okay? Real quick here, I'm going to divide both sides by 150. I think that goes in even. Make sure you type all the zeros. That usually gets me. I get e to the 0.5x equals 600. Now, this is a weird one because if I want to have it, if I have an e, it makes more sense to do the natural log. Move the 0.5x out in front, which doesn't look like a 0.5x. Let me fix that. That's up here. 0.5x. Okay. And then take the natural log over here. Now the natural log of e is just 1. So this is just 0.5x times 1. So we're going to divide both sides by 0.5 and be done. So x equals, now if you wanted an exact answer, you could just leave that mess. But I'm going to type it in, natural log of 600, close parenthesis, then divide by 0.5. I get 12.0444. 0.793, and that would round to a 9. All right, so that's what to do when you have an x in the exponent. The next kind is when you have a single log expression, okay? Isolate it and then rewrite as an exponential sentence. So guys, what that means is if you have, log base 7 of x equals y, we're going to rewrite it 7 to the y equals x. So we're just using this idea. That's the rewrite. So this is already isolated. The base down here is 10. So when we rewrite it, it's 10 to the third. Remember, the answer is the exponent, equals 2x plus 20. This is 1,000. I'm going to subtract 20. Divide by 2. And I get 490 equals x. If I want to go back and type log, parenthesis brought up, 2 times 490 plus 20, hit enter, I get 3. The only other thing you have to do on this one is isolate the log first. So you have the natural log of x plus 2 equals 6 divided by 3, or 2. Because of the ln, our base is e, so we have e to the second equals x plus 2. So if you wanted an exact answer here, you could say it is e to the second minus 2 equals x. If you want an approximation, I'm going to go second ln, or e to the power of 2, arrow to the right, minus 2 is 5.3891. Okay, let me just make sure we're okay with how we type that. I did second ln, brought up e to the little power, then I put a 2 in there, or arrow to the right, minus 2. Okay, I get this crazy long decimal. If I went back up here to check it, I'd have 3 times the natural log of, I'm going to do a crazy calculator trick here, that answer, why do I have extra parentheses? Did I put that in there? That previous answer that we got up there, plus 2, equals, and it should come out exactly 6, because remember I used that whole answer. All right. All right, if you have several log expressions, okay, you will need to compact them. But these are two very different problems here, okay? This one has logs on both sides. This one does not. So there's two very different patterns going on here. This one you're going to compact as the log of 2x plus means times. And then you've compacted these into a single log equals 3, or condensed them into a single log, okay? Then this was a base 10, so you're rewriting as 10 to the third equals 2x squared, because I just simplified that. Then you would divide both sides by 2. This is 1,000 divided by 2 is 500. Then you would take the square root. Now, we could simplify this. I'm fine with a decimal, but I have a question. Can you put a negative in here? Remember, we can't take the log of a negative number. And here the log is just log of x. So I can't take the log of negative square root of 500. So I have to throw that one away. And the only answer is square root of 500, which is 10 square roots of 5, or if you did square root of 500, it would be 22.3607. Here it was 100 times 5, or 10 square roots of 5, and that's actually accurate. Okay, or approximately this. I'm okay with either one. This one is different because there's going to be log on each side after we simplify. We're going to put this up here, so we have the ln, natural log of x squared, and then minus means divided by 3. Okay, and it's actually the natural log of all of that equals the natural log of 12. Well, because we have a log on each side, some teachers call this exponentiating, and that's what we did over here, really, what they like to call exponentiating. When you have a natural log, you can say, I'm going to take this as e to this power equals e to this power. So the e and the ln undo each other, and we get x squared over 3. And over here, because this was e and ln, they undo each other, and you just get 12. I just look at it and I go, if the log of this equals the log of this, then these numbers in here have to be equal, okay? So I don't usually write this step. I just say they have to be equal. So then if I multiply the 3 over here, I get 36, which would be plus or minus 6 when I square root each side. Now, if it had started here, I could put a negative 6 in here and square it, and I'd be golden. It would become positive. But up here it said the ln of x, so if you put a negative 6 in that first step, the natural log of negative 6 doesn't exist. If you put a negative 6 in right there, it's illegal. So we have to get rid of that one and just say x equals 6. All right, so I'm going to let you try these 4 problems right here on your own. And when you have finished, you can go to the notes that I'm going to attach, and I will have the answers for those. Okay, I'll show my work so you can check. I am going to go ahead and talk about a couple more things here, though. In the assignment, there's a packet. You have 4 different sections to it. This is the section called Solving Exponentials with a Common Base. It says rewrite the equation using your common base, use the properties to simplify, then use the one-to-one property. If you have something like 3 to the y equals 3 to the 7, the only way that's true is if y equals 7, okay? So when you get the bases the same, the exponents have to be the same. So that's the idea. I'm going to do the evens with you real quick. This, again, already has the same bases, so therefore the exponents have to be equal. I'm not going to spend too much time on this because you guys are good with the algebra. So if we plug it back in, we'd get 4 minus 1 is 3, 5 minus 2 is 3, e cubed equals e cubed, so that checks. All right, on this one, remember, when you have an x squared times an x to the third, you keep the x and you add the exponents. So here we keep the 8 and we add the exponents. X squared plus, k squared plus k plus 2k minus 9. Over here, same thing, keep the base, add the exponents. Whew, that's a mess. But now because they're both to base 8, the exponents have to be equal. I'm going to combine those as I write it down. So I get k squared plus 3k minus 9 equals 4k plus 11. Then I have a k squared, so I have to make it equal to 0. If I subtract 4k over here, I'll get negative 1. If I subtract 11, I'll get negative 20. Which factors k minus 5 and k plus 4. I know I'm going fast, sorry. I think you all could figure this out. If I factored it right, then we get k equals 5 or negative 4. Now remember, you can't take a log of a negative number, but you can put a negative in the exponent. So there's no need to throw these away. You could go ahead and plug it back in all those places if you wanted to check them, but they are both going to work. All right. This is a little bit tricky, but this should have an exact answer because this can be written as a power of 4. Anybody remember that? 4 times 4 times 4 is 64. So therefore, this is 4 to the negative 3 power would be 1 over 64. Okay, and over here we have 4 to the a squared minus 4. Once we've written them both as the same base, the exponents have to be equal. So we get negative 3 equals a squared minus 4. If I add 4 over here, I get 1. If I square root, I get plus or minus 1. And either one that I put in here, if I square negative 1, I get 1, minus 4 is negative 3, and 4 to the negative 3 is 1 over 64. If I put a positive 1, I get the same thing, so these both work. This is all can be written as base 12, so this would be 12 to the negative 1. Now, when we have an exponent, we are multiplying, so be really careful because students will write down negative 1 times 4x plus 3 and forget to distribute. But this is going to be a negative 1 times this when we do that. And then it said times 12 to the x squared. And what do we do with the exponents? When we multiply, we add. And then over here, it just stays 2x plus 13. I guess I'm going to write this out one more time here. This is all 12 to the this mess. So then we can get rid and say, I'm going to distribute up here. Negative 4x minus 3 plus x squared equals this exponent, which was a 2x plus 13. I'm going to move everything over this way so that it equals 0. Sorry if I'm skipping too many steps for some of you. But over here I will have an x squared minus 6x minus 16 equals 0, which would factor x minus 8 and x plus 2, or x equals 8 or negative 2. And there's no reason you can't put both of those back in here. They will both work, okay? All right, moving on. The second kind I have for you is solving exponential. This is the same thing, but if you can't use a common base, in other words, if you don't have 2 to the x equals 2 to the 7th, instead you have 3 to the x equals 2 to the 7th or something, okay? And it can't get the same base, then you're going to have to use logs. So you isolate. We already did these on the other notes, by the way. Isolate, take the log of both sides, expand if necessary, check for extraneous solutions. This one does say, okay? So here, because it's base e, you would just take the natural log of both sides, move the x out front. X times ln of e, which is just 1. So you end up with the natural log of 140, or whatever decimal that is, okay? .9416. All right. This next one down here, just take the log of both sides, because that's all you can do when x is in the exponent. I'm going to use, I guess I'll use log. Not really a fan because it's a lot more writing to me. So I moved that out in front when I took the log of both sides. Now, you can do this any way you want from here on out. You could distribute this. Personally, I would divide this log over to the other side. If I got to have messy decimals, I would rather they were on one side. So I'm going to write 2x minus 5 equals, and divide that. You don't have to do it in that order. All right, I'm going to leave you guys to finish that. You would add 5, divide by 2, and it will work when you put it back in, okay? You can check on the notes. I'll come back and finish it on the notes if you're worried. All right, this one, You cannot combine those, okay? So what you have to do instead is divide both sides by -2 to isolate, and you get 8 to the 4 minus x equals 25. Then you take the log of both sides, and I'm going to be lazy this time and do ln. Then again, you could do this in any order you wanted. If you wanted to distribute it through there, you can. I'm just going to divide both sides by the natural log of 8. So I get 4 minus x equals ln of 25, close parenthesis, divided by natural log of 8 is 1.54795 or 780. Then if I subtract 4, I get negative x equals negative 2.4520, which means x is 2.4250. If I plug that back in up here, I just want to check one for you. Negative 2 parenthesis 8 to the power of 4 minus 2.4250 is negative 52.9. So did I make a little sign mistake somewhere or a decimal mistake? Because that seems kind of far away. I'm going to redo it again. ln of 25 divided by ln of 8, 1.5480. Subtract 4. Change the sign. Oh, yes, I did make a mistake. This should be... This should have been 2452. Transpose those numbers. So then when I type it, I get negative 2 parenthesis 8 close parenthesis to the power of 4 minus 2.452, and then I get negative 50.00. Okay, so I transposed some numbers. I don't know how I managed to catch that, but anyway. All right, moving on. We have more than one log. So this is a kind called log equals log. So when these are equal, you can put a big giant E here and exponentiate each side if you want. So you get k squared minus 4k equals k plus 14. If I subtracted the 1k over here, I'd have 5k, subtract 14. If that factors minus 7 and plus 2. All right, I do want to talk about extraneous solutions because we get them on these kind of lot. All right, so this started out, can the negative 2 work is the question. Okay, so if you put a negative 2 back in here and square it, you would get 4. If you put a negative 2 in here, negative 4 times negative 2 would be plus 8. So 4 plus 8 would be 12. If you put a negative 2 over here, you will also get a positive 12. So the negative does actually work here. So both of them are okay. The positive should always work unless you made a factoring mistake. All right, so you guys do this one, which is super easy. All right. Okay, now I have a big mess. I have to rewrite this. I can't just get rid of the logs, okay? You cannot just do this and try to solve. No. The only way you can do that is if there is a single log on each side. Okay? So we're going to go back and rewrite this as log base 7 of w plus 6 divided by 5w minus 3 equals log base 7 of 8 to the 1/3 power, which is the cubed root of 8, which is 2. So then I end up, I have a single log equals a single log, so I have w plus 6 over 5w minus 3 equals 2. So if I multiply the 5w minus 3 up onto this side, then I could finish. Okay, I'm going to go real fast. W plus 6 equals 10w minus 6, which would be 9w equals 12. 12 divided by 3 would be, or by 9 would be 4/3. Yikes, that's not a pretty answer, but I'm going to try typing it back in. It should work. So if I do 4/3 plus 6, and then divide it by quantity 5 times 4/3 minus 3. That's all 2, so I'd have the log base 7 of 2 equals 2. So yeah, I kind of skipped. I didn't put it back in the first step, but it did check. So I didn't make a silly mistake. All right, so this is a hot mess, but if I rewrote this, I'd have the natural log of a plus 1 quantity squared equals. This is cubing and square rooting, and this is divide. So I'm going to write 80 over 5, and then to the power of 3/2, which is this is 16, and 16 to the 3/2 would be 16 square rooted and then cubed, which would be 4 cubed, or 64. So now I have a single log. I can get rid of this. And actually, you could square root both sides here. You could also FOIL this hot mess out and do a plus 1 times a plus 1. But I think I'm going to take the cheater route here, or the short route, and square root both sides. So I get a plus 1 equals, but you have to write plus or minus 8. So then if you subtract 1 over there, you would have a equals -9, or -1 plus 8 would be 7. If you'd FOILed it all out and moved the 64 over, you'd have factors of 63 that make, in the middle would have been a 2a, so 9 and 7. All right, anyway. Uh-oh, we finally get to throw an answer away. If I put a -9 back in here, I will have natural log of -8, which you cannot do. Okay? So this one is garbage. Only this one works. This is extraneous. So you can't take the natural log of -9 plus 1. All right. Last section. Sorry, this is long, but lots of examples here today. This says if you have the log equals a number, okay, condense and isolate, and then rewrite, okay? Or what some teachers call exponentiate. I always just think of it as rewriting, but I just want to make sure that those of you who did this last year can remember it's just called exponentiating. To get rid of the natural log, we're going to do e to the power on both sides. Or you're just going to rewrite it as e to the 9th equals 2a, which is what it means, okay? But if you exponentiate both sides, then this undoes each other, and you have 2a equals e to the 9th. So this is my way of rewriting. This way is called exponentiating. Doesn't matter, you get the same answer. Divide both sides by 2, and you have e to the 9th over 2, which is approximately 4051.5, and I'm out of room. You should carry some more decimals, but I'm going with it. Okay? A couple more evens here. This one, the 2 would go up here. Oh, that's horrible. No, let's not do that. That would be icky. Let's isolate. Okay, read the directions, Hofbauer. So I'm going to subtract 4 from both sides. Then I'm going to divide both sides by 2. And I'm going to have the log base 9 of k squared plus 2k equals 1/2. Then I'm going to rewrite or exponentiate. If you like exponentiate, you're doing a 9 here and a 9 here. If you're rewriting, it's 9 to the 1/2 equals k squared plus 2k. Well, this means square root of 9, so that's 3. If I subtract it over here, I get k squared plus 2k minus 3, which factors k plus 3, k minus 1, k equals -3 or 1. If I put a negative number back in here, I get 9 minus 6 is 3. If I put a positive 1 in there, I get 1 plus 2 is 3. So this case, they both work. Because of the squared on that k, it does work. All right, I think this might be the last problem. This time we need to raise this to the 1/3, which is the cubed root of 27, which is 3. So this becomes the natural log of 3. Plus means times. Equals 4. So I condensed those. Okay. Now this is e because of base or the ln. So we have 3 times x minus 5 equals e to the 4th. If you wanted an exact answer here, you could certainly divide both sides by 3. You could distribute, that would work, but I like to be lazy. Divide the 3 over here, and then add the 5 over here. So this is your exact answer, or you could go with a decimal, okay? You could just change this to a decimal, divide it by 3, add 5, or distribute, whatever, however you want to come about the answer as a decimal. I got is 23.1994. Okay, whatever order you did that in. So right here you could have distributed and said 3x minus 15 equals, and if you just did e to the 4th, you'd have 54.5982. Then if you added 15 and then divided by 3, you'd still get this answer. Okay. So any way you want to go about it, that's what you should end up with. Please tell me that's the last one. Oh no, one more. All right. Minus means divide. And this side still had a log base 2. So when you rewrite, this would be 2 to the 2nd power equals. Okay, 2 to the 2nd power is 4. I'm going to need to multiply that over to that side. So I'll have 4 times 3c minus 5. Then I'm going to subtract it all back over here. So I will end up with 0 equals c squared minus 12c plus 20. which would factor c minus 10 and c minus 2. So I get c equals 10 or 2. And because they're both positive, I think they're going to work. Yes. Just be careful that when you plug that 2 back in, this parenthesis does come out positive. So those both work. Okay. Go back, do the odds, and check the key. That's it for today.